Hello students, welcome to the Turito School Foundation program. Today we are going to discuss the very important topic for that students, that is multiples and submultiples measurement of physical quantities. Just we have to see for the 6th class students, we would like to go for that one. Yes, okay. Yeah, it is better to have the look into that matter. We would like to go for the Turito School Foundation program. Yeah. And we would like to utilize this opportunity, right. For the 6th class students, measurement is very important, and we would like to go through the measurement of macroscopic and microscopic phenomenon. All right. If you are going to look into the matter of the microscopic phenomenon, the magnitude is going to be very less. If you are going to measure that radius of orbit or radius of the orbit of the revolving electron, and also you can go for that nucleus and the size of nucleus and the radius of nucleus and radius of the atom. All these are very less. So, we would like to express in the multiples and submultiples. We would like to go for the expression, right. Okay, we would like to go for that multiples and submultiples and measurement of the physical quantities. All right, we would like to go for this, right. While you are discussing about all, we would like to go for that, right. That is, you can take, this is, yeah, force acting on this area. You can take that force per unit area. That gives the pressure. You would like to go for this one, right. Now, you can take that P is equal to F by A. All right. If you are going to express that area, it is going to be meter square or centimeter square, whatever. Now, you would like to go for that, this area, that is going to be identified that meter square or centimeter square. Yes. So, you have to get that square also, right. You can take meter into meter. All right. You are going to get that multiplication of this a fundamental quantity, that is going to be length, it is very clear. Now, if you are going to measure the atmospheric pressure, we would like to consider that force acting on the unit area. We are going to take that level of that mercury, which is going to be acted upon the force due to the presence of the environment. Yeah. There exists a force on that area, we would like to measure that, right. Yes, let us go for that. Another one also we would like to get for that multiples and submultiples. Just you have to see, it is going to be, you know, power that is equal to is the rate of doing work. Just you have to confirm. Yes, you have to see, this is power P is equal to work by time. You have to take that. So, you can take that P, that is going to be W by T. At the same time, you can get that work done is equal to energy. Yeah, you have to confirm that. Here, work done, it is going to be force into displacement. Yes, you can take that Newton, displacement is going to be meter, let us assume 1 Newton, that is going to be 1 joule. Easily you will confirm that 1 joule, it is the derived unit. You will get this 1 Newton meter, just you have to take this one is equal to 1 joule. So, work done, we would like to talk about that work done, it is nothing but energy. Okay, all right. Now, you are going to have the look into that matter, that is going to be, yeah, joule per second, just you have to get this one, second. Sometimes you can take that kilojoule per hour, just you have to take that. We are going to get this one. Just we would like to go for that, yeah, right. So, you will take that 10 power 3 joules is equal to 1 kilojoule, it is very clear. Okay. Here, while you are going to measure the power consumption by the electrical appliances, we would like to talk about that power consumption is equal to kilowatt hour. It's going to be kilowatt hour, right. You can take that, it's going to be watt, it's going to be, we would like to go for this one, work done, it's going to be joules or kilojoules, then we can take that, we will measure the power consumption under all these things with the help of these multiples and submultiples. Let us see if you are going to express that force here. So, 1 Newton is equal to 10 power 5 dyne, it is very clear. Yes, you can take that 1 joule, just we have to take that 1 joule, that is equal to 10 power minus 7 x, 10 power 7 x, yeah, we would like to get this one. So, these are the multiples, just we have to rise that power which is going to be represented in different system of units, all right, it is very clear, we would like to go for that. Here, what is the use of multiples and submultiples in the measurement? If you want to express the magnitude of a physical quantity in the view of its measurement, we would like to rise the power of the 10, just you have to get this one. If you want to express the diameter of the sun, just we have to get, if you want to express the radius of an atom, just you have to take that. You know, if you are going to get that radius of atom, that is going to be identified, this is going to be getting that 1 angstrom units. So, let us assume 10 power minus 10 meter. If you want to get that microscopic parameter, yeah, estimate that order of the magnitude, it is going to be very small, all right. Just you have to represent, yes. At the same time, we would like to get that very large parameters and its magnitude. If you are going to take that light which has been travelled in a 1 year, we would like to go for that light year, the distance travelled by the light in a year, which is going to be 9.46 into 10 to the power of 15 meter. Easily we will convert, that is going to be 9.5 into 10 to the power of 12 kilometers. You have to take that light year, it is going to be 46 into 10 to the power of, we would like to go for that 15 meter, just we would like to get, was approximately 9.5 into 10 to the power of 12 kilometer. We can estimate this one is approximately equal to 10 to the power of 13 kilometer, just we would like to. So, in the process of measurement, we would like to express that value in the multiples and submultiples. We would like to go for this one, right. That is what you have to get that estimation by the order of magnitude large and small. We encounter the objects widely different in their sizes. If you want to measure the size of a bacteria, if you are going to get that size of bacteria, you have to get that it's order of 10 power minus 6 meter, just we have to take that. We would like to get that micrometer. So, these are all about to know the microscopic and macroscopic measurements, which are going to be expressed in terms of the multiples and submultiples. It's very clear. Let us go for another one. Yes, you have to confirm. As of just you know the dust particle, if you are going to get that measurement of that size of a mountain, if you have to get that measurement of dust particles size, what you have to compare that very large and very small. Yes, we would like to get that beyond that limits, yeah, beyond the macroscopic limits. Our naked eye can't able to see that sometimes also. So, we would like to express the value in terms of the multiples and submultiples, just we have to see, it is very clear, right. Just you can take that, yeah. You have to get that larger value. If you are going to get that macroscopic parameters regarding to that mountains and some, if you are going to get that observable physical quantities, if you are going to get that the mountains and moon and earth and planets and all these moving objects which are going to be having their magnitude, which is very small, which is very large. If we are going to get that very small, that is going to be virus and bacteria. Yes, electron is revolving in its orbit around the nucleus. If you know that, you have to estimate that. What is the need to estimate that? Right. If you are going to get that for macroscopic changes, which is responsible. Microscopic parameters, microscopic changes, they are the responsible. Yeah, responsible, we have to get that. That is very clear, we would like to get that. So, if you are going to get that transfer of heat, if you are going to get that transfer of energy, if you are identifying that current, all these are going to be due to the microscopic changes, just we have to get that. Yes, that is what, if you are going to get that smaller objects such as bacterial atoms, electron belonging to the microscopic small world, you have to get that large world, macroscopic and microscopic. It is very clear, if you are going to get that diagnosis one body, you want to get that, know about that reasons behind that what we are all suffering. So, you are going to get that one drop of blood, just any part of the body, just you want to analysis, that is going to be identified, that the presence of the particles, presence of that cells, normal growth, abnormal growth of the cells and the virus presence and their count, and everything is going to be identified with the microscopic measurement. Yes, they are very small, their size is going to be very small and their number is also going to be the small, just you have to express in the submultiples and multiples, right. We would like to go for that. Just you have to see, this is going to be identified that, yeah, if you are going to get the diameter of the sun, it is going to be that large value. Yes, if you are going to get this one, you have to identify this. Yes, you have to take this one, just yes, you are going to get that the just two cases, diameter of sun Here also you will get that diameter of the hydrogen atom. You have to get this one, this is very clear, you would like to go for this one. So, if you are identifying that, yes, if you are identifying this, just you will get that, that is yeah, that much of the small value you are going to express that with the concerned unit, that is going to be the angstrom, just you have to confirm that. In a system of unit, the measurement of the microscopic parameters are going to be expressed. You have to see this is going to be that one, just you have to see this one, this is very clear, you would like to get this one, right. You have to identify that number which is going to be identified by raising the 10 power some value, that power which is going to be indicates that macroscopic or microscopic. If you are getting that positive term, if you are getting that negative, it is going to be microscopic, just we have to see, this is very clear. We would like to go for this one, what we have seen, it is going to be very clear, everyone has to identify this one, this is going to be getting, this is the multiple part, this is the numerical value, this is the multiple, just we have to see, this is going to be getting that, this is also getting that multiple, that is 1.06 into 1 by 10 power 10. Yeah, you are going to get that 1.39 into 10 power 10 meter. It is very clear. We can say that the diameter of sun, it is going to be 1.39 into 10 to the power of 9 meter. It is very clear. We would like to go for that. Here, we would like to confirm that 1.39 is the numerical value. It is going to be between 1 and 10, it is very near to that 10, so 9.9 some value, just we would like to approximate as a 10. So, that numerical value we would like to keep that it is in between 1 to 10, it is very clear. After that we are going to express as in the form, that is going to be 10 power some x or y or z, whatever that x, y, z, that is going to be the positive, which is going to represent that smaller or very larger value, whatever it may be. It is very clear, we would like to get that. Here 10 power 9, what is 10 power 9? It is the exponential part, we would like to represent that total value, either that is going to be the very small or it is going to be the very large, we would like to get this one. So, finally we can conclude that matter, in order to represent that microscopic and macroscopic measurements, we would like to use the multiples and submultiples. So, we have to express that value in terms of the multiples or submultiples, just we have to see, it is very clear, right. Just we would like to in the, finally we can approximate in the order of 10 power 10 times, 10 power 9 times, the total value is going to be expressed in terms of that exponent, just you have to take, it is going to be the 10 power, generally we are going to get that size of atom, it is going to be the 10 power minus 10 meters, it is order of 1 angstrom units. Yeah, if you are going to get this one, if you are going to look into that matter of the nucleus also, it is going to be the about 10 power minus 15 meter in the range. So, we are having that some standard notations to represent the microscopic and macroscopic phenomenon. All right, let us go for that. We would like to go for this one, right. Similarly, the order of magnitude of diameter of the hydrogen atom, it is going to be 10 power minus 9 meter, just we have to see, this is going to be getting that. yeah, you have to get that multiples and submultiples. Just we would like to go for this one, right. Some practical units of mass in various branches of physics, we would like to get this one. Let us see that. We would like to go for this one, all these are going to be getting that. While we are going to get that reference carbon atom, you will get that one atomic mass, it is going to be 1.67 into 10 to the power of minus 27 kg. Just we have to see all these parameters, just we have to get this one. Some practical units of mass in various branches of physics, we would like to go for this one. Yes, time also we would like to get this one. So, 1 shake and 1 minute, and we would like to get that. Here we would like to discuss about that. Yeah, it is very clear. This is the nucleus, just we have to confirm. So, we would like to go for this one. Yes, we would like to go for this orbit one. So, the electrons are going to, yes, you would like to go for, yes, it is easy for the representation. So, yes, this is going to be the electron, very clear, you can get that. It is going to be excited, and sometimes you can represent that electron here, which is going to be excited electron. So, this is also electron. Here we would like to talk about that excitation. So, again you know very well about that electron is revolving in its orbit. In order to maintain the sustainability, it is going to have that excitation and de-excitation. So, you know very well about that absorption and emission of energy. Sometimes it needs energy, let us talk about this one. It will excite here and it will de-excite, right. What about the time? It is going to be around 10 power minus 8 seconds, just we have to t. You would like to get this one to 10 power, yeah, we would like to go for this one, 9 seconds to 10 power minus 4 seconds. What is the time interval? Just we have to see. So, for excitation, it is very clear, de-excitation, yeah, it is around at 10 power minus 9 seconds to 10 power minus 4 seconds. Very clear, in order to maintain the stability, it needs, yeah, while you are going to higher classes, just you will learn about that, how the electron is going to be sustainable while it was revolving in its orbit. How long does it maintains that energy, which is going to be the constant. It is very clear, whenever we would like to represent the time, we would like to express that value. In order to explain that the interaction, when it is going to be excited, when it is going to be de-excited, we have to look into that matter. That is going to be 10 to the, it takes the time that is around 10 power minus 9 seconds to 10 power minus 4 seconds. It is very clear, within that period of time it will excite and it will de-excite. What is the need? You know very well about that. In order to gain that energy or in order to lose that, to maintain the stability, it is very clear. Whenever it has some excessive amount of energy, it has to be released in the form of contact. That is very clear, no doubt at all. So, all these microscopic interactions are going to be expressed in terms of these multiples and submultiples. Yes or no? It is very clear. That is what we would like to go for this one. Okay, all right. We would like to go for that explanation on all these microscopic phenomena. It is very clear. Sometimes you are going to get that celestial bodies and their motion, and you have to get that the magnitudes are going to be high. Just you have to see. Right. Yes, you have to take that. We'd like to go for this one. All these are going to be identified. Let's have the look. Yeah, if you are going to get that measurement of the time, some practical units. Okay, in decade, 100 years, it's going to be getting that century, millennium, and all these things. These are going to be large. It's very clear. What you have seen in the previous case. Yes, if you have seen that, how the time is going to be the very small in order to represent the one interaction. Say yes or no? Just you have to see, that is very clear. All right, you would like to go for that one. Let's see how it is going to be very small. Yes, it is very small, just we have to see 10 power minus 9 seconds to 10 power minus 4 seconds, very small. But if you have seen that, all these values, right. Okay, all right. So, we would like to go for that next one, just some special units of length, you have to get this one, please. So, micron, just you have to get that 1 micron, it is going to be equal to 10 power minus 6 meters, all right, it is very clear. And also you have taken that, yes, you have taken 1 centimeter, that is equal to 10 power minus 2, just you have to get this one. Here you would like to get this one, yeah, what they have been changed that meters to centimeter, it is very clear, it is going to be 1 10 power 2, just you have to get that, it is very clear. So, 10 power minus 6 meter, it is going to be 10 power minus 6 into 10 power 2 centimeter, it is very clear, you are all getting that 10 power minus 4 centimeter. So, you are all getting that size of the bacteria, which is going to be estimated with the help of microscopic study. Yes, all these are going to be identified that. Okay, yeah. If you are going to get that to represent the very small value of that length, and you have to take that large value also. Yeah, it is very clear. Next, we would like to go for that Angstrom unit, which is very useful to get that the size of atom. All right, right. You will go for this one. If you are going to get this one, yeah, you are identifying that the size of atom, which is going to be represented in the form of, just if you are going to get this one, yeah, if you are going to get this one, it is Angstrom units. While you are going to talk about that volume, it is going to be 4 by 3 pi r cube. Just you have to take that, this is going to be 4 by 3 pi into Angstrom whole cube, just you have to get this one. All right, you will get that, suppose that is going to be 4 pi into 10 to the power of minus 10 meter whole cube, it is very clear. We can express that value regarding to that one atom, you can express the size, that is useful. Yeah, you will get that Angstrom, 1 Angstrom is equal to 10 power minus 10 meter, it is very clear, it is going to be 10 power minus 10. If you are going into that nucleus, what happened, let us see, it is going to be very small value, that is going to be order of 10 power minus 13 centimeter. Let us see what, if you are going to get that. Yeah, if you are going to get that astronomical unit, the mean distance of the earth from the sun, it is very clear. We would like to go for this value, how it is going to be the large, it is very clear. Yes, if you are going to get that, its value is going to be 1.5 into 10 to the power of 11 meter, it is very clear. As compared to that, the magnitude, which is limited to small value and which is going to be having that larger value, it is very clear, we would like to go for that. Yeah, light year also it is going to be getting that, it is 9.46 into 10 to the power of 15 meter, it is very clear, which was approximated, that is 9.5 into 10 to the power of 12 kilometer, very clear, we would like to go for this one, all right. We can have that large value and smaller values, all right. Okay, it's easy for you, you will get that. Yes. In the coming classes also we would like to have that multiples and submultiples. We would like to discuss that more problems related to these multiples and submultiples. Have a nice day. Thank you very much.